Welcome Astha Yadav for Algorand Python.
Hey, hi everyone. Thank you so much for coming to this session. And I'm Astha Yadav. And can we all just sit down? Or, yeah, thank you so much. Okay, so before we begin this session, I would like to have like a few questions answered so that it's a little bit like interactive and you are also involved. So how many of you over here are like into Python? Like you know how to write Python code? Almost like everyone. That's really good. Okay, then another question for you guys. How many of you know about blockchain? Even if you haven't built on blockchain, but you just like know. Wow, that's also like a good number. Like in other conferences where we go, like we also hear people saying that we don't know anything about blockchain. Okay, and anyone over here who has like already built on Algorand or have heard about Algorand before? Quite few. Okay, so our talk today is titled as Algorand Python. And also, I would want to understand maybe from someone who could like just tell, like, um, do you think blockchain development has been hard for you, or you have restrained yourself from developing something on blockchain because you faced like some issues? Anyone over here? Yes. Yes, please. Yeah. Like, what was the reason?
Understanding the concept altogether, that was the beginning. And then whatever the tools were that had to be built had a lot of coding involved in it.
It's a coding language restriction, probably like a very
Yeah.
like very niche language is required for you to learn in order to get it right. That's actually a very valid point, and that's what we are going to solve today. Like, what if I told you that you could actually use Python and still you'll be able to develop your applications on blockchain? Would you love to do that, or would you be willing to do that? Okay, that's great. Okay, so like you said, the tooling is sometimes hard, sometimes the languages are like, for example, for different blockchains, we'll have to go through different languages. So if, for example, we want to validate our use case, we have to first learn new languages. For example, we have to learn Solidity, we'll have to learn Viper, we'll have to learn Rust. And even in our ecosystem, we also had like a very different language, which was called as Pytel. I'm not sure if anyone was like able to like build that well over like on our platform as well. So yeah, and as you mentioned, like there are concepts which even feel foreign to people who are like experienced, software developers. So what we thought was, why don't we remove this kind of friction? And that is what today's talk is all about. So you don't need to have like a specialized skill. Now even blockchain development becomes like a natural extension of skills that developers already know and they use in their daily life. So a little bit about myself before we dive into all of this. So I'm Astha Yadav. I've been a DevRel advocate at Algorand Foundation. I have more than like 6 years of experience. So initially I was a developer before, and then I thought that, okay, there is a lot of friction over here, and how can we actually like help developers build cool stuff without like feeling lost or frustrated. So I also have like expertise in cryptography, ZK, and like many of us over here, I've also like started exploring how we can use AI as well. So happy to chat with everyone who is into anything related to this, even Algorand blockchain, or even if you're against blockchain, even if you feel that it's worthless. Yes, bring in. Okay, so let's start with why do we even need blockchain? So let's start with a real case scenario, and that's actually a photo of one of the startups that are building in Afghanistan. So let's go to Afghanistan first. So that's a country wherein only 6% of people actually have access to bank accounts. So there are not enough people who have access to banking, as well as, on top of that, there is actual shortage of physical cash. So then how do people actually go about their daily lives? How do they pay their bills? How do they do their grocery shopping? So over here, if you can see, there's a lady who gives out her QR code, and the other person who's the vendor, they scan the QR code and they're able to make payment even without giving credit card or debit card or cash. Now that's what HisabPay is doing. They have removed the friction of actually understanding blockchain. Even though they are using blockchain underneath, they are using Algorand, still they have abstracted away the complexity, and they have been able to build something which is like in such harsh conditions wherein, for example, even centralized systems, even government cannot help a lot. So if you look at the numbers, they have been working in 400 districts, 34 provinces in Afghanistan. In the last 12 months, they have been able to make 4.6 million plus transactions, 70K humanitarian cash transfers, which are worth like $3 million. And they have also been able to get 2 million electricity bill payments, which are worth like $41 million. And not only that, they have started expanding to Syria as well. And they are being used by global organizations like World Food Programme and Save the Children. So what does HisabPay solve over here? The first thing that they solve is financial inclusion, which is they are able to work very well in such situations wherein basic like financial systems are not able to. And the second thing that they are able to crack is trust without intermediaries. So without any middleman, they are able to gain trust and able to make such transactions. Now, before we move to the other use cases that we have on blockchain, I think we all do understand what blockchain is, but for a few of us to just be on the same page. So blockchain is a digital ledger which is distributed among a lot of nodes, maybe thousands, maybe 10,000s, maybe even more than that. And they don't have a single entity who can control it. So what that means is that if, for example, someone wants to verify and get their transaction included into blockchain, they will have to go through an agreement process wherein some of the nodes would come together, would decide whether and validate whether that particular transaction is correct or not, and check like other validations, which we call as consensus mechanisms, and that's like different for different blockchains. And once they do that and it's included in the blockchain, then no one can actually tamper with it. So it's kind of like immutable. So we say, like there was a hype in 2021 when people used to say that, oh, let's use blockchain for literally everything. We don't say that anymore. We say that, okay, let's see where all blockchain can add value. So let's see three major categories. So the first is disintermediation, which really means that we are cutting out the middleman. So for example, if we have an example of an insurance company, so there are like many insurance companies, for example, if we take an example of health insurance. Now, like that has happened to me personally. So if, for example, I'm sick, I've taken my health insurance, and I go to claim it, and I say that, okay, hey, you like told me that I can claim my insurance based on my condition. So they say that, okay, you did not read the whole clause on page number so and so. We've written it somewhere. You did not ask us, so we did not tell you. But we won't give you the claim. Or at times, even if they give claim, you will have to like send your documents, and it might take maybe a month or two, and it's really hectic. So what we could do is, instead of that, we could use blockchain over here, which will act as kind of like an escrow account wherein you'll put money and all the conditions are defined before. And those conditions are actually public. So that means that even as a user, I could read all of these conditions. And if, for example, these conditions are met, automatically the transfer of, like I could do the claim, right? The second one is data integrity, which is basically for people who want to know where your stuff comes from. So basically, if the blockchain would help verify provenance, which is a fancy word for saying origin. So if you would have heard about news about like luxury goods and fashion, so there is a lot of like counterfeits over there. Now, if like I want to understand that, okay, where does this particular luxury brand's manufacturer is? Like, do they even use the best quality of like goods that they actually claim? So by using blockchain, I could do that. I could actually verify the provenance, I could verify the authenticity and ownership of data through transparent record keeping. Another example that could be, and I would really love to hear if some people are actually facing that, is if, for example, in AI, some people say that, okay, we want to train data, but we are not really sure whether that data actually is correct or not. Has anyone faced this problem? Okay, so we do have people who have faced this problem, right? So using blockchain before and having all the data recorded on blockchain, you could actually have a way out wherein you could be sure that, okay, that hasn't been tampered with. Now, next is market access. Now, you could actually invest in real estate, for example. So with tokenization and fractional ownership, you could actually invest in properties wherein it is very difficult to do with, if, for example, and we'll see that later in this presentation, that it's tough, for example, if we have like a rental property, for example, in US, we have to put in almost like 150K USD, which is tough for us to do that. But you could actually fractionalize and you could just put a small percentage of that, and it could be as less as like $50. Now, the other way of having like a great market access that blockchain solves is micropayments. Now, what I mean by that is, so for example, many of us would use like streaming platforms like Netflix or other apps. And I know like almost everyone does that, right? But what we do these days is we pay them for the whole month. But do we watch that much? Sometimes yes, sometimes no. So what if we have a streaming service wherein we could pay per second or per minute of the amount of time we have watched instead of paying for flat subscription? So that is also one of the use cases that we could have with blockchain. Now let's see some of the use cases that are actually built on Algorand. So the first one is Lofty, which I just defined like a few minutes ago, which is basically used to fractionalize property ownership. So what they've done is they are able to fractionalize more than 180 properties across 21 US states. They have currently like 7,000 monthly active users, and they are like actually they have $3 million in rental income, which is actually great if you see. Even like in Bangalore, if you see, we have to actually pay approximately like 1 CR in India to in Bangalore to have, for example, even 1 BHK. And if we want to put it out on rental, we still, I think the maximum that we can go in terms of ownership is 50%, or even, I don't think it could be like less than that. But now with Lofty, you could have like 1% of the ownership. Then the second one is LabTrace, which is, I think, a really good use case. So what happened was that when people used to do MRI scans for patients, for example, for babies and for small children, and they wanted to check tumors in them, so the doctors used to show them that, okay, we are doing your MRI scans, for example, every month or every 2 months. But when they were showing the patients, they used to show it in a different way. They used to tamper with the data, and they used to show that instead of your tumor being decreased, it is increasing, so that they could take out money from them. So what LabTrace solved was, they have like MRIs in their MRI scanners. They have introduced a way wherein the time that it scans your MRI, it timestamps it and sends it to blockchain, to Algorand actually. So now your data cannot be tampered with, and the authenticity of scan is guaranteed. And so they are, okay, cool. Is it happening from a long time? Okay, I'll take no as the answer. Okay. Okay, so we have like a lot of use cases over here that are already built on Algorand, and these are like real world use cases that are solving real problems. So let's come, like we have already seen the happy part of blockchain. Now let's come to why blockchain development is hard. So if we see here in Web 2 development, we have different components. So we have front end wherein users can interact with, we have back end where your business logic goes, and we have databases wherein you could store information. But when it comes to blockchain, there are two more paths that are added. Now, one is blockchain network, which acts as like the distributed ledger that we were talking about, where each node can process like blocks, wherein you could participate in the consensus protocol, which was when we had to agree, or if you want to store data, or if you want to execute your smart contract functions, which actually contains all your logic of your application. And then we have a virtual machine, which provides a constrained execution environment where your code would run. So basically, all the transactions get executed on the virtual machine. Now, the thing with this virtual machine is that every operation would cost fees. There are strict limitations on computation, on memory usage, on execution time. And on top of that, for every blockchain, you'll have to learn a new language, which is actually a barrier for many developers. So we understood this problem that for widespread adoption, we would need to solve an entirely different problem, which is to solve developer experience. So at Algorand, first let's go to the core features that Algorand has. And then we'll go into how we solved developer experience in terms of coding. So we say that Algorand is an energy efficient because we use pure proof of stake as compared to mining, which was being used by Bitcoin, which was very energy which was in like a lot of energy consumption was going. So using proof of stake, we have like ensured that we are economically sustainable. Then we have quantum secure. So we are protecting the chain's history against future quantum threats using Falcon signatures. Then we say that we are a single layer architecture. So we say that we don't have any layer 2s because we all share the same security guarantees and performance. And also like all the assets that are created, we don't have to actually code it because it's already there on the protocol level. Then we say that we have instant transaction finality, which means that once a transaction goes into the block, it's final, so you don't need multiple confirmations. There is no reorgs or forks that you need. So there are like some chains wherein you have to like kind of wait like few minutes so that you can be sure that your transaction is final and has been included in the blockchain. So you don't need that over here. Then we can like it's having like consistently high throughput, which means that there are thousands of transactions that are getting executed per second. And we have very low fees. And we are going to see all of the numbers in the next slide. And the favorite part is that we have like, since the time we have launched on mainnet, we have zero downtime. So it has been 100% available from the past, like I think June 2019. No, June? Yeah, June 2019. Okay, so let's see Algorand today by the numbers. So we have been able to achieve almost more than 10,000 transactions per second. I think we've actually like almost reached to 14,000 as well, but for being on a safe side, we say like 10,000 transactions. So it's comparable to Visa, and I think like many of us use Visa in our day-to-day lives as well. Now, the block time, which is like the time, how much time it takes to create a block, is generally 3 seconds, like under 3 seconds. I think the best we've reached over here is 2.8 seconds, but if the network is congested, it would take up to 3 or 3.2 seconds as well. Now the transaction fees is very low. It's like 0.01 algos. And these algo transaction fees are not always static, and it would vary when consensus incentivization is also going to get implemented. But if you see over here, on an average, you could do like thousands of transactions, and that would even like not even cost you like a cup of coffee. And then we see a lot of zeros over here, which we are very happy with. So we have 0 seconds to reach transaction finality, we have 0 forks, and we have had 0 downtime. And with all of these features, we are able to have more than 50 million blocks, more than 3 billion transactions, and we have 2.4 million monthly active users. And all of this was recorded on May 14th. So till now, it would have increased, like in terms of blocks, transactions, etc., not in terms of transaction fees. Okay, so let's come to the most interesting part over here. Now, since every one of us understand that, okay, we can write in Python. So what is Algorand Python? So Algorand Python is a statically typed framework for writing Algorand smart contracts. So it maintains all the semantics, all the syntax of Python language. And you can also work with your standard Python tooling, for example, like linting, formatting, etc. So it integrates with your tools. You can auto-generate typed clients for seamless interactions. Now, since like Python is getting executed on the virtual machine that we saw earlier, so it is actually a partial implementation. So we can also like discuss on what all constraints are there. So for example, we can't use exceptions. We don't have context managers. We don't have lambdas or async code. And also in terms of what we could actually store. So the integers are 64 bits and bytes are actually capped at 4096 and everything needs type annotations. So you get Python's feel, you get strict typing strength, and you also get blockchain safety. Now, for some of the nerds over here who are actually interested to know how does Python actually compile down, and I just see some smiles over here to say that yeah, we actually want to know. Okay, so yes, definitely. So as developers who want to build applications on top of the compiler, I would say that you don't actually need to know what happens under the hood, but it's always like a good practice to know like the team has actually worked so much to have Python on blockchain. So yeah, so you would write your smart contracts in Python. Now it gets converted to Puya abstract syntax tree, which means that it gets like broken down into a tree structure that shows that program flows are there, like for example, like functions, loops, variables, etc. Then AWST is Algorand Web Syntax Tree, which is proprietary to Algorand. So the engineers have developed it in a way that it is transformed into a closer, into a form that is closer to Algorand logic, and that is like easier to optimize your smart contracts. Then it gets converted to intermediate representation, which is kind of like a middleware between high-level Python and low-level TEAL. So when we go to TEAL, so TEAL is transaction execution approval language, which is our smart contract, like Algorand smart contract language. Now that your program is converted to TEAL, it will finally be compiled to bytecode, which is basically what Algorand virtual machine would actually run. So just to give you context of what hello world in TEAL would look like. So since our virtual machine, and I think almost every virtual machines are stack-based processors, so they would understand something like this, which means that they'll understand assembly-like languages, which would have something like concat, pushint, return, etc. But you don't actually need to learn that or understand that. What you need to understand is something like this, which is way simpler than TEAL. So for writing hello world, or let's do it a little bit interactive way. So can anyone guess what this particular code is doing? Anyone? Do we have any hands up who want to just tell like on a high level what it's doing? Like we don't expect to understand like we like ask you imports and stuffs like that. Or Akfu?
It's trying to push hello plus name to the blockchain level.
So
Trying to create a contract with this data.
It is creating contract.
yes, it is creating contract. And what does define hello mean? Like what do you think is this function doing?
Just receiving hello plus a name as
Yes,
right?
yes. So what we are doing is we are first importing stuff so that we are able to create smart contracts. We see arc4 over here, which is basically a standard, which is actually like a special base class. So you inherit that base class and you say that everything that we write this class will be considered as an Algorand smart contract. And then we define ABI method, which is like a decorator of which makes these functions callable from like outside the contract. And then we define our function. We say that, okay, like take an input with the name, with the parameter name as name, which is in the form of a string, and then you'll return hello and the name, which is actually correct. So I would like to say that you are already blockchain developers on Algorand. Yes.
So is there a way to like, is there any kind of trend, or is there no trend?
So when you're returning, so I'll show you like later on as well that there is a UI tool, and also like on your like front end, you could actually whatever you return, you could visualize that. So you don't actually need like consoles for that. So if you return over here like hello and the name, that would give you whatever you want to print.
But what if the code is very complex and I want to debug statements in between something?
For that, we do have like AVM debugger. So that would help you to, that's like actually a VS Code visualizer. Sorry, what happened? Okay. So that's like a VS Code debugger tool, which helps you to even like go line by line. You can also see your storages. You could see like what's exactly happening and after each and every step. So does that work for you? Okay. So now that we have seen that, okay, we can read from the blockchain, let's try to write on blockchain. So to write on blockchain, we can use like different storages. So one of them is a box storage, wherein you could store in form of like key value store. So this one is a little bit tricky one. Can anyone guess what's happening over here? So maybe like if someone could guess what's happening inside init. Yeah.
Same decorator we are using, and deposit is actually creating a block on blockchain.
Um, yes. So, so deposit method is taking a payment transaction and and it's storing the data. So for example, if we want to track how much like people are depositing, we would say that, okay, just take out the amount and see who is actually depositing. So you will deposit against the account address over here. And in the init, it is same as we do it in Python. So that would be run once when we deploy it, and that would initialize our box map, which is like a key value storage. And in that, we have defined that, okay, the key should be account, and the value should be in the form of an integer, that is uint. Okay. So then, apart from the smart contract language, what all does AlgoKit offer us? So AlgoKit also offers a comprehensive, like it's basically a comprehensive developer toolkit, which offers a lot of tools. Like from the start, you could also build production level like applications. Now, we start with AlgoKit CLI, which is a command line interface, wherein you could start with as simple as command like AlgoKit init, and that would ask you some questions. So we also have Algorand TypeScript, which is another language to write smart contracts. And that would say that, okay, in which language you want to write your smart contracts. It will give you a really good template, and they can also like give you the front end part of it. So you don't actually need to write any wallet based code. You don't need to write any testing initially. You don't need to write separate deployment scripts, and it also gives you a local network. So you don't need to directly start with test network. You don't need to think about creating like demo accounts. You don't need to think about having funds in that. So all of that is handled by local-ent, which is a sandboxed environment that is run on your Docker. Now, once you have this running, as we looked at earlier, you have a Puya compiler, which compiles your Python down to bytecode, which your virtual machine can actually execute. Now we have AlgoKit utils as well. So utils is a utility library which helps you abstract away a lot of things like accounts, transactions, and it gives you a very easy way of doing it. So for example, if you want to integrate your smart contract, you could do that using utils. Then we have client generator, which is a way to create a typed application client. So that would provide you an easy to use interface to deploy and call your smart contracts. We also have testnet dispenser, which is basically going to give you a lot of funds. So you don't have to generally care about that you will have to like wait for 24 hours and you only have, for example, 0.01 algos. And then as we mentioned earlier, we have an AVM debugger, which helps you to debug your contracts line by line. Okay. Can we go ahead with this slide or shall we stop? Okay. Okay, so since time is up, so this is the roadmap that we are looking forward to. This was like released in July. This is an 18-month. Sorry that we can't go go towards it like today, but if you want to meet us outside, you can just come at our booth. We provide like hands-on demonstrations. We can discuss your specific use cases which are relevant to your industry. We can help you get connected to the resources to get started, and there are a lot of like startup programs and upcoming hackathons that are there. And this is a QR that you could like scan and you can get started. So thank you so much.